What's going on, guys? Long time no see. It's been probably like a year and a half since I've made a video, so I figured I would come back and start a whole new series. This is episode number 1 of Basic Electrical Theory.
My name is Andrew. I am a rancher, a marksman, an outdoorsman, and a bladesmith. I've spent most of my life seeking adventure in one way or another, or in one place or another, and I would like to share all of that with you.
It's a well-known fact that anybody working in the electrical industry should have at least a basic comprehension of the electrical units used to measure electrical power. If you don't have that, you shouldn't be messing with electricity, and you should call a qualified person. Amps starts with an A. Also known as the C word, current. Amps, that's the measure of the flow of electricity through the wire. So usually we like to compare this to water flowing through a pipe. Some of you plumbers might be able to wrap your mind around this. So there might be water flowing through the pipe and it's got a certain amount of pressure behind it. That is not the amps. The amps is the current flow. It's the total amount of water flowing through that pipe, except it's electricity flowing through a wire. Amps. Now, we can spend a lot of time and talk about the flow of electrons through the wire and the science and how amps are technically capable of being measured with coulombs and all that, but most of anyone in the entire world doesn't need to know that. We need to know that amps are a thing that exist, and that amps are basically the flow, the current flow of electricity or electrons through that wire. That's all you need to know right now. Move on. Okay, next, volts. With a V, volts. So if amps are the current, then volts are going to be the pressure. Volts is going to be the amount of pressure that push that current through that wire. Simple, right? All you need to know. Don't need to know anything else at all about it right now, just that. After we get past the two most basic parts of electrical power, or the two most basic ways of measuring it rather, you are going to step into resistance, or ohms, measured with the Greek omega symbol here. So if you want to think of this again as water going through a pipe, you have a certain amount of pressure, and you always have that amount of pressure. Let's say that pressure is 120 volts. So we have that continuous amount of voltage constantly pushing current through the wire or water through the pipe. Well, what happens if you add some resistance, like a nozzle used to create like a high pressure stream of water coming out the pipe? If you add a resistor to a circuit, then essentially what you're going to do is you're going to keep the same amount of pressure or the same amount of voltage. So we have 120, it's going to continue to be 120 volts, but we've added a resistor, and that reduces the current flow in the circuit. Likewise, you may have a certain amount of water pressure in your pipes. You're going to continue to have that same amount of pressure, but you're going to have lower current flow. After that, you have watts. What did he say? Watts are power. At least that's how a lot of people like to refer to it. Watts are the total draw of power from like an appliance out the wall, essentially. You might have the voltage that pushes the electricity through, you might have current flow, and you might have resistance that's going to drop current, but watts is the total amount of power consumed, in a sense. Now, unfortunately, in order to fully understand basic electrical theory, you do need to understand a little bit of math. Now, in math, there's something called variables. Variables are essentially placeholders or like letters that correspond to certain values. So we use variables to define amps, volts, resistance, watts. So amps is usually defined with an I. Volts typically defined with an E. Resistance typically defined with an R, go figure. And watts typically defined with a P for power, like I said. So these variables are used in what's called Ohm's law. Now you can use Ohm's law and the way that all these interrelate to each other to make calculations to decide what size your circuits are going to be, what size the wires are going to be in that circuit and all that. But it also helps you understand when you're measuring this kind of stuff that if you have 120 volts and you have, let's say, your resistance is 10, then you're going to be pulling 12 amps. Yeah, that sounds about right. So I'm going to show you how to do that. Let's go back to what I just said here a second ago. Typical circuit in a house is going to be 120 volts. So let's say that the typical branch circuit in a house is usually 15 amps. Using Ohm's law, we can see what the resistance of that circuit should be mathematically. More or less, it'll be about the same. You might not actually have exactly 120. You might have 122. You might have 118. You know, it's a bummer that it can never be 100% accurate. But using these values, we can see what the resistance is in that circuit. Now, if you're not super good at math like me, you might want to pick one of these up. You probably already have one. It's an Uglies. Right on the front is an Ohm's law wheel. Gives you all the mathematical equations used to calculate each of these. If we wanted to find resistance, we already have our volts and our amps, or rather we have our E and we have our I, and we want to get our R. So based upon the information we have available, we know that we can divide E by I, and that will equal R. So 120 divided by 15, that goes in there 8 times. The resistance of that circuit is 8 ohms. So, super quick on the math here. Let me break down the whole thing for you. I'm going to draw a picture of the wheel so you guys can see it. Actually, I don't know why I'm trying to draw a picture for you guys when I literally have a picture right here. So you can see that I did resistance here a second ago, and I did E divided by I is equal to R. Now, if I don't have I might have P for watts, or I might not have the E for voltage, but I do have the P and the I. And for the amps, E divided by R, or voltage divided by resistance, is the amps. If you wanted to get, let's say, your watts is equal to your voltage times your current. So if you know you have a 120 volt circuit and then that you have 15 amps in there, you just multiply that and you know how many watts that circuit is even capable of. So you don't need to do you don't need to go and look for labels. You can just do the math and understand, get your code book, and then size everything up. Okay, now let's slow back down and do a couple math problems here. Just so we get all of it. Because while that is simple for a lot of people, pretty simple for me, I might even be going too fast. Some people don't quite get it. So the best thing to do is to do a couple of math problems. I'm going to do a couple practice ones, and then you can get like your own numbers, plug them in, and do a bunch of practice problems on your own. I'm just going to give you ideas of how to build them, so then it'll help you to understand this concept. So back to the original problem here. And I think all the problems, I'm just going to have them all be 120 for your voltage. So remember, E is for your volts, I is for your amps, R is for your resistance, and P is for your watts. So we already have 120 volts and we already have 15 amps. Let's go and find our resistance. Now, if we look at our Ohm's law wheel, we can look under resistance, and then we can see that the resistance is equal to E divided by I. So E divided by I is 8. There we go. Next, we need to find our watts. So we can find watts super easy with any of those now. Take a look right here at your watts. Let's just go E times I. So E times I, 120 times 15, well, 120 times 10 is 1200, half of that is 600, so it's 1800 watts. I don't have a calculator, so I have to do math my way. So there you go. Now we have all the information, or at least all the basic information for this circuit. 120 volt circuit with a 15 amp branch circuit is going to have a resistance of 8. And the watts generated will be 1800 watts. So let's start that circuit from a different area here, okay? So we have a 120 volt circuit, and we know that the branch circuit is 1800 watts, or at least that's what that's generating. But we don't know what the rest is. So we can use our Ohm's law wheel. Let's look for, let's say, resistance first. Resistance is actually going to be a little bit tricky on this one. It is, see it right, oh, there it is. It's going to be E squared divided by P. So you're going to have to square 120 and then divide it by 1800. So if you don't know what squared means, is that just means that you're going to multiply 120 by 120. And then whatever that number is, you're going to divide it by 1800. Well, we already know that it's 8. So let's go ahead and put that down. We can do the math, but just get a calculator. Be man. Next, what we're going to do is we're going to look for the amps. Amps should be super easy. On your Ohm's law wheel here, you can take P and divide it by E. So that is 1800 divided by 120, and that is 15. There you go. Super easy, right? Let's do one more. Same circuit again, just because I don't have a calculator and I don't want to do the math. But if I had a calculator, I could do this math a lot easier than in my head. So right now, I don't know how much voltage is in this circuit, but I know I've got 15 amps, and I was able to measure resistance, and the resistance is 8 ohms. So I can look for volts next, and what we're going to do is we're going to take R, volts R times I. 8 times 15 is 120. See, I told you all the math, no matter what, if you have two numbers, you can find all of it. The math is super simple, and it proves that electricity works because it all makes sense. So you have your 120, your 15, your 8. Let's just find the watts again. We've already done this one. There's your watts. Look at the wheel again. E times I, or voltage times amps. 15 times 120 is 1800. So what you do, go and grab a couple of different numbers for yourself. I mean, instead of always being 120, why don't you change it up, make one 115, and then you can watch how the numbers in the circuit change. And then maybe make one 117, and then do a couple different variations. Don't always start with having the voltage. Start with having two different numbers, each time, and do like 5 or 6 of each. Not a big problem, and just sort of make it a little bit different every time, and you'll start to understand how it all works and realize that it's all actually really simple. And technically, like, This is proof that electricity works, bro. It's kind of cool, actually. In the next video, I'm going to show you guys how to measure voltage with a multimeter out of a receptacle. Should be super easy, super simple, but probably a teeny bit of a learning curve so we don't blow ourselves up. But I'll see you guys in the next video, okay?